All right, you mathletes, this is going to be our last section for the entire class. So we are almost done. So the last section deals with one-sided limits and continuous functions. So we're going to start with the continuity stuff first. So a function is continuous, and I'm going to give you the basic definition. When you get into calculus next semester, there's a formal definition, so you'll look at that. So we're going to look at this one first, just because it's easier to kind of grasp and get your head around. So a graph is continuous if it has no holes, jumps, skips, vertical asymptotes, gaps, etc. So in other words, you can draw the whole graph without ever lifting your pencil. So a function that would be continuous, or a type of function, would obviously be some sort of a polynomial. So something that's like going like that. Because you can draw the whole thing without ever lifting your pencil. There's no hole in it, there's no asymptote, etc. So that would be continuous. And then if you add one like this, that is definitely not continuous, because if you saw how I drew it, I had to lift my pencil up. So I have a hole here, I've got a big old gap, so that would be no, not continuous. Okay, so that's the difference between continuous and one that isn't. So example 1, discuss the continuity of each function. So you don't have the graph, but you can still get a pretty good idea. So like for A, is there anything that you're not allowed to plug into that function? Like would anything give you a 0 in a denominator, a negative in a root, or something that would come out as undefined? No, every number is totally fine to plug in there. You would always get a result. So this is continuous on the entire real line, so negative infinity to infinity. Now over here on G, there's one number that you can't plug in for X, and that would be the 4. So it's continuous everywhere else except at the 4. So when you write out your interval, it's everything but the 4. So negative infinity to 4, union 4 to infinity. So that last example wasn't continuous everywhere. So that value of 4 was where your continuity was broken or where it was destroyed. So another way to say that is that's where the function was discontinuous. So these discontinuities fall into 2 categories. They can either be removable or non-removable. So if there is a discontinuity, it's going to be one of these 2 types. So let's go ahead and define them so you can see what they are. So we have types of discontinuities. So the first one is where a function can be made continuous. So that's removable. So you're doing something to the function and getting whatever that discontinuity is, like that term cancels out. So then it's continuous there. And then the second one is when you can't make it continuous no matter what you do. So you cannot remove it. So that is your non-removable discontinuity. So when we discuss, the continuity of each function, now that we have a definition for discontinuities, we're going to need to state where the discontinuities are and then also determine what type it is. So I'll stop the video here and then we'll actually do that in the next one.